Dinet. My IT number is IT22092038. And in our deep learning project, we are classifying tea leaf diseases using Kaggle dataset from Sri Lanka. My part is Model 1, a custom CNN, one of our supervised learning models. The dataset has about 880 images across 8 classes. Let's dive into my code and the results. First, I analyze the dataset and the show that in plot bar chart the output shown as imbalance, that red leaf spot has 143 images but healthy only 74. This visualizes the distribution guiding our pre-processing to handle imbalance effectively. For pre-processing, I used Keras image data generator. It rescales image to 1 divided by 255. It applies augmentation like rotating and flipping, and we splits 80% of for training and 20% for validation. Class weights balance and imbalance during training to improve performance on smaller classes like healthy. My custom CNN model built from the scratch. It has two Convo 2D layers with 32 and 64 filters, ReLU activation and max pooling, followed by flatten a dense layer with 128 units, dropout at 0.5 and softmax output for 8 classes. I complied it with Adam optimizer and trained for 10 epochs. The validation accuracy reached to 30%. Here's the evaluation code. The classification report shows in the precision. This is our prediction. Thank you. That's my part. Move to the next meme.
For our problem of diseases in tree leaves, to identify the disease from the leaf, I have built a VGG16 model to identify the disease. In VGG16 model, it also a convolutional neural network, but not as usual one. It's used 16 layers in the neural network for image classification, as well as it resizes images into 222 by 222 pixels, and also data augmentation also done in there. And in here, as optimizer, I have used Adam optimizer and the layering rate 0.001. Fine tunes last five. I have fine tuned last 5 layers, and there are 20 approaches. In here, this is the my model. I have resized the images into 224 pixels, and also at the activation function in the dense layer I use value function. As dropout I have used 0.5, and also as activation function I have used softmax function. As the end result, I have got low F scores because of the low count of the data as the images.
Hi, I am Murali Atavaga. In this project, I use SE4050, a deep convolutional neural network for classifying tea leaf disease. Here, I imported ResNet 50 model. I imported ResNet 50 model from Keras application. Then I used it as a feature extractor by loading pre-trained weights from ImageNet. And after that, and after that and after that I loads pre-trained weights and uh, and uh, and removes the fully connected layers at the top, so we can add our own classifier. And uh, and here I added a flatten layer to convert feature maps to 1D vector, and dense layer with 256 units with ReLU, and dropout layer point 0.5 to reduce overfitting, and final dense layer with softmax for multi-class qualification for T-leaves disease. And here I compiled my model with Adam. It is good for adaptive learning rates, and I added learning rate as 0.001. It is uh, a small value. It's good for stable fine tuning, and I use loss function as a categorical cross entropy. And after that after that I trained a model from 20 ports, and class weights helps handle any imbalance between disease and categories. During training I monitored both training accuracy and validation accuracy. After training I evaluate the model using validation data set. This shows how well the model pre-detect each these disease class, and the confusion matrix highlights where miscalification occurred, and useful for understanding which disease looks very familiar. uh, and also uh, and also finally I test it with a single image. This part loads a saved model and predicts the disease type for a new image.
Hello, I'm Mr. Kamshanle. My IT number is IT2225692, and I worked on model for efficient net B naught. Model is a transfer learning based approach that uses pre-trained ImageNet weights. I removed the top layers and added a global average pooling layer, a dense layer with 128 ReLU neurons, a dropout layer of 0.5 to prevent overfitting, and a dense output layer with 8 softmax neurons, one for each T-leaf class. The optimizer I used was Adam with a learning rate of 0.001, and I fine-tuned the last 20 layers of the model for 20 epochs with a batch size of 32. And here's the code implementation I wrote in Python using TensorFlow and Keras. This code builds the model by taking efficient net B naught as the base, freezing its layers, and adding my own fully connected layers for classification. I then trained it for 20 epochs using class weighted training to balance the dataset. Finally, I evaluated the model using a classification report and a confusion matrix. The confusion matrix shows the most images were misclassified and only the red leaf spot class achieved good recall. This low accuracy was mainly because our dataset was small and imbalanced. The base layers were frozen during training. Thank you.